Hi everyone, and welcome to our video on some exam questions related to the nth term of a quadratic sequence. Our first question states, write down the next two terms in the following quadratic sequence. So remember, a quadratic sequence has two differences. So let's work out the first difference first. So 9 to get to 13, you need to add 4. 13 to get to 19, you need to add 6. 19 to get to 27, you need to add 8. Now, as you can see, these differences each have a difference of 2. So the next one is also going to have a difference of 2. You're going to add 2 again. So you need to add 10 onto this number. That's going to give you 37, and then you're going to add 12. So the difference is 2 again. So the next number is going to be 49. So our two numbers in the sequence is 37 and 49. So 37 and 49. And this would be worth 2 marks. Next question, it says write down the next two terms in the following quadratic sequence. So again, let's work out the difference. So minus 5 to get to 0, you need to add 5. 0 to get to 9, you need to add 9. 9 to get to 22, you need to add 13. And as you can see, each of these differences have the same secondary difference. So you're adding 4 and then you're adding 4. So the next one, you're going to add 4 and then you're going to add 4. So this one is going to become 17. So you're going to add 17 and then you're going to add 21. Okay, so 22 add 17 is going to give you 39, and then 39 add 21 is going to get you 60. So the next two numbers in the sequence are going to be 39 and 60. Okay, so 39 and 60, and that would be worth 2 marks. Next question, it says the nth term of a sequence is 2n squared plus 4n minus 1. Work out the 10th term in the sequence. So whenever we have n, that tells you the position of the number in the sequence. So it tells you the position of the term in the sequence. So if we're finding the 10th term, instead of n, we're just going to put in 10. So which is this? So we have 2n squared plus 4n minus 1. So instead of n, we're going to substitute in 10. So 2 10 squared plus 4 10 minus 1. And remember, bid mass, you do your brackets before anything else, and then you do your indices. So 10 squared is going to give you 100, and then multiply it by 2 is going to give you 200. And then you're going to add that onto 4 multiplied by 10, which is 40, subtract 1, which is 39. So 200 add 39 is going to get you 239. And that will be your answer for 2 marks. Okay. Next question, it says here are the first 5 terms of a quadratic sequence, 5, 11, 19, 29, and 41. Find an expression in terms of n for the nth term of this sequence. So let's write out the sequence. So we have 5, 11, 19, 29, and 41. Let's work out the first difference. So the first difference, 5 to get to 11, add 6, 11 to get to 19, add 8, 19 to get to 29, add 10, 29 to get to 41, add 12. Now you need to work out the second difference. So let's work out the second difference. So 6 to get to 8, you need to add 2. 8 to get to 10, you need to add 2. 10 to get to 12, you need to add 2. And the second difference must be the same. If it's the same, it's a quadratic expression. So we have plus 2, and plus 2. Now, the next step is you need to do the second difference, whatever it may be, and you need to divide it by 2. So in this case, the second difference is 2. So you would do 2 divided by 2, giving you 1. And this tells you the coefficient in front of n squared. So it tells you how many n squareds there are. So we've done the first part, we've worked out how many n squareds there are. Now what you do, because we have 1 n squared, you write out the sequence for 1 n squared. So 1 n squared, you keep substituting in 1, 2, 3, 4, 5 in place of n. So if we substitute in 1 squared multiplied by 1 is 1, 2 squared multiplied by 1 is 4, 3 squared multiplied by 1 is 9, 4 squared multiplied by 1 is 16, 5 squared multiplied by 1 is 25. So that's our n squared sequence. Now, our sequence is over here, 5, 11, 19, 29, and 41. So let's write our sequence here. So our sequence is 5, 11, 19, 29, and 41. Now you need to see how to get from the n squared sequence to our sequence. What do you have to do each time in order to get from the n squared sequence to our sequence? Okay, so how do we get from 1 to 5? So as you can see, you add 4. 4 to 11, you add 7. 9 to 19, you add 10. 16 to 29, you add 13. 25 to 41, you add 16. We've just generated ourselves another sequence. Now let's write out the new sequence. So the new sequence is 4, 7, 10, 13, and 16. Now we need to work out the nth term of this sequence. Okay, so again, 4 to get to 7, you add 3, 7 to get to 10, add 3, 10 to get to 13, add 3, 13 to get to 16, add 3. So as you can see, all of the differences are the same. That tells you it's a linear sequence because we've got the first difference, which is all the same. So it's positive 3, so it's going to be 3n. And because it's positive 3, we're going to write out the positive 3 times table on the top. So 3, 6, 9, 12, 15. How do we get from this number to this number? We add 1. This number to this number, we add 1. This number to this number, we add 1. And as you can see, each time we're adding 1. So we're just going to add 1 to the end. Now we have all the information. We just need to generate the expression. So we have 3n plus 1 over here, and we have 1n squared over here. Obviously, we wouldn't write it as 1n squared. We would just write it as n squared. We just combine them together to get our final answer, which is n squared plus 3n plus 1. And this would be worth 4 marks. Now you can check your answer by substituting in 1 in the place of n, you should get 5. 2 in the place of n, you should get 11. 3 in the place of n, you should get 19. 4 in the place of n, you should get 29. And 5 in the place of n, you should get 41. Okay, that's a way of checking your answer. Okay, next question now. So it says here are the first 5 terms of a quadratic sequence. 6, 10, 16, 24, and 34. Now it says we need to show that the nth term is this. So we just need to prove that this is the nth term. So let's write out our sequence. So we have 6, 10, 16, 24, and 34. Let's work out our first difference. So our first difference is going to be between 6 and 10, add 4, 10 and 16, add 6, 16 and 24, add 8, 24 to 34, add 10. Now you need to work out your second difference. So second difference, 4 to 6, add 2, 6 to 8, add 2, 8 to 10, add 2. Now remember, you do the second difference divided by 2. So the second difference divided by 2. So the second difference in this case is positive 2. So we're going to do positive 2 divided by 2, giving us 1, and that's the coefficient in front of n squared. Now, because it's 1n squared, let's work out the sequence of 1n squared. So we have 1n squared. So 1 squared times 1 is 1. 2 squared times 1 is 4. 3 squared times 1 is 9. 4 squared times 1 is 16. 5 squared times 1 is 25. Now, what's our sequence, which we have? So our sequence is 6, 10, 16, 24, and 34. So 6, 10, 16, 24, and 34. Now you need to get from our n squared sequence to our sequence. So we're adding 5, we're adding 6, we're adding 7, we're adding 8, and we're adding 9. So we've just generated ourselves another sequence. Okay, so we have 5, 6, 7, 8, 9. Let's work out the nth term of this sequence. As you can see, the first difference is the same. We're adding 1 each time. Okay, so we're adding 1 each time. So it's going to be just n, and then we're going to write down the positive 1 times table at the top. So 1, 2, 3, 4, 5. How do you get from the top number to the bottom number each time? As you can see, we need to add 4 each time. So each time, to get from the top number to the bottom, we add 4. So we're just going to add that onto there. Now we have all our information. So we have the n squared and we have the nth term. We just combine them together to get that n squared plus n plus 4 is the nth term. And we've just proved that that is correct. That would get you 4 marks. Now it says, hence determine whether 136 is a term in the sequence. So all we need to do whenever we need to determine a number is in a sequence, we just make the expression equal to that number. So we would just make n squared plus n plus 4 equal to 136. Okay, and now you can factorize this. So first of all, get all the numbers on one side and make it equal to 0. So let's subtract 136 from both sides to get that n squared plus n minus 132 is equal to 0. Now you can factorize this into 2 pairs of brackets. So we need numbers which multiply to negative 132 and sum to positive 1. We can have positive 12 and negative 11. So we can have n plus 12 and n minus 11, and that's equal to 0. So positive 12, I'll just write it here. 12 multiplied by negative 11 is negative 132. That's what we need. And 12 add negative 11 gives us positive 1. And that's what we need over here. So we know that this is correct. So if we look now, we need to solve for n. So we just make them equal to 0. So n plus 12 is equal to 0. Subtract 12 from both sides, n is equal to negative 12. And the other one, n minus 11 is equal to 0. Add 11 to both sides, n is equal to 11. Remember, you can't have a negative number, so we can't have this solution. So our solution is 11. That tells us that 136 is the 11th term in the sequence. So yes, 136 is the 11th term in the sequence, and that would be worth 3 marks. And that is it for this video. Thanks for watching. I hope you liked it. And one last thing, please subscribe, hit the like button and the notification bell.